Okay, this video is going to go through the Unit 1 mock paper that you've just done. I've put the mark scheme on Moodle, so you're able to check that. But this is just in case you wanted to know how you get to a certain answer. I'll just be going through the paper explaining how you do it as we go. Okay, so question 1. Table 1 shows some data about fundamental particles in an atom. An atom of hydrogen can be represented as 1H. Use data from Table 1 to calculate the mass of this hydrogen atom. So what they want you to think about here is what particles does an atom of hydrogen contain? If you look at the periodic table, you will see it has a relative atomic mass of 1 and the atomic number is 1. That means it has 1 proton and 1 electron, and that's it, no neutrons. So what you need to do is take the mass of the proton and the mass of the electron and add them together. And that's it. So the answer there should be 1.6734 times 10 to the minus 24. And that's it. That's how you do question 1A1. A lot of people were thinking that there was a neutron in the hydrogen atom or just a proton, but just think about it. In terms of looking at hydrogen in the periodic table, look at what the proton number and the mass number tells you. Okay, part 2. Which one of the following would not be deflected by an electric field? So what they're asking you to do is to use your mass spectrometer knowledge here. The proton is positively charged, the neutron is neutral, the electron is negatively charged. You should know from your mass spectrometry work that something is deflected by an electric field if it has a charge. So therefore the one that doesn't have a charge is the neutron, which is B. And that was pretty well done, so well done. Okay, so the next set of questions then. B part 1, calculate the percentage abundance of boron 10 in this sample of boron. Now this is a very tricky question, this is very mathsy. There's a couple of ways to go about this. Some of you would have been able to sort of understand it immediately, some of you it would have taken a bit longer. To get the first mark, you would need to write something like this, where in terms of a mathematical approach, 10x plus 11y over x plus y equals 10.8. That would get you 1 mark. And what you're seeing here is that the abundances, we don't know what they are, but we know that actually whatever you times 10 by and what you times 11 by, if you add those together, that will equal 10.8. Another way of looking at it is thinking, okay, so if there was an equal amount, 50% boron 10, 50% boron 11, then the relative atomic mass would be 10.5, it would be dead in the middle. As it's more towards the 11, then we know that there's going to be more of boron 11. And the fact that it's 10.8 indicates that there is 80% of boron 11 and 20% of boron 10. So actually the answer that they're looking for is 20%. Now, as I said, that is quite difficult, and if you don't do maths, you would have found that a little bit more difficult, so don't worry. Part 2. State in terms of fundamental particles why the isotopes boron 10 and 11 have similar chemical reactions. It's because this is a very standard question because they have the same number of electrons or the same electron configuration. Remember that electrons determine the chemical properties. Yes, they have the same number of protons, but actually protons don't determine the chemical reactions. Okay, part C. Complete table 2 by suggesting a value for the third ionisation of boron. What you want to think about here is what group is boron in, how many electrons does it have in its outer shell, and so where the big jump is going to be. Looking at the periodic table, boron is in group 3. So that means once it loses its third electron, there's going to be a big jump between the third and the fourth. So actually the one we want to fill in is not where the big jump is. The big jump will be after the third and before the fourth. So what they're looking for there, and you can get the mark for any number between 3,500 and 10,000. So the way I would do it, I would look at the approximate jump between the first and the second. That's 800 to 2420, which is a jump of about 1620. So I would do the same there. I would add that on and I'd get about 4,040. So if it was me, I'd probably write about 4,000. Oops, there we go. Okay, part D. Write an equation to show the process when the second ionisation of boron is measured. Include state symbols in your equation. I've underlined that on so many of your papers because you haven't done that. Okay, the second ionisation is when you're going from a 1 plus ion to a 2 plus ion. So boron plus is going to boron 2 plus. The way it does that is that it loses an electron. But we have to put the state symbols in. So that is the correct answer. Part E, explain why the second ionisation energy of boron is higher than the first. A couple of things you can put here. The idea that the electron being removed is now closer to the nucleus, or it's being removed from a positive ion. So I would just say that the electron being removed is now closer to the nucleus. My writing's appalling on this because I'm using my finger on the iPad. Sorry about that. Okay. There are a few things that they will allow there, but it's the key thing that the electron is closer to the nucleus. Okay, so we start here with the calculation questions. When heated, iron 3 nitrate, and they give you the MR, which is good, is converted into iron 3 oxide, nitrogen dioxide and oxygen. Part 1, calculate the amount in moles of iron 3 nitrate in the 2.16 gram sample. Give your answer to 3 significant figures. Some people are still confused between significant figures and decimal places. So what you should do here, moles equals mass over MR. So 2.16 divided by 241.8. If I do that on the calculator, then I get 0.00893 and then it goes on. So significant figures start with the first non-zero number. So we've got 0.00, they don't count as significant figures, and then we've got 893. So that should be your answer. You can also write it as 8.93 times 10 to the minus 3. If you didn't do that to 3 significant figures, you would lose the mark. Part 2, calculate the amount in moles of oxygen gas produced in this reaction. So we need to look at the molar ratios. So we've just worked out the moles of iron nitrate, and they want the moles of oxygen. So what you've just worked out, 0.00893, whoops, should be 893, not 899, or whatever number you got, divide it by 4, times it by 3. Okay, in the mark scheme it says times it by 0.75, that's exactly the same thing. You should get, when you divide it by 4 and times it by 3, approximately 0.00669 or 670. They're not too fussed about the precision there because they've penalised precision in the previous question, but it should be around that. Part 3, calculate the volume in metres cubed of nitrogen dioxide gas. They've given you the temperature and the pressure produced from the original amount of iron 3 nitrate. So this time we need to work out the moles of nitrogen dioxide, which is there in the equation. So the moles, firstly, you've got to work out by taking either the moles of iron 3 nitrate or the moles of oxygen. It doesn't matter which way you do it. If you start off with the moles of iron nitrate, then you want to times it by 3 because you've got a 4:12 ratio. Hopefully you can see that at the top. So it should be 0.00893 times 3. And that will give you 0.00893 times 3, gives you 0.02679 or thereabouts. The ideal gas equation, hopefully you've worked out you've got to use that here. You've got a volume, you've got, they want you to work out the volume, you've got a temperature, pressure, and they've given you the gas constant. That's a big clue. PV equals nRT. Rearrange that, V equals nRT over P. So, what have we got? The moles are 0.02679. R is 8.31. Temperature. Now, they've given us a temperature of 293 degrees Celsius. We need to convert that into Kelvin by adding 273, and you get 566. So let me just rub that out so I've got a bit more room. So we're going to times that by 566 divided by the pressure, which is 100 kilopascals, but that's got to be converted into pascals, so that should be 100,000. Okay, and then you should get as your answer 0.00126 meters cubed. Now they wanted the volume in meters cubed, and it comes out in meters cubed, so that is what you need to write, so that is correct. In terms of in this question what you get the marks for, you might be a bit confused. You get the marks for, firstly, converting the temperature and the pressure. So having those numbers, that was what I was looking for 1 mark. For the second mark, it was for working out the moles correctly, either by timesing your answer to part 1 by 3, or you could do your answer to part 2, which is this one here, by 4. Either one is fine, but that's what I was looking for there. The third mark is for the rearrangement of PV equals nRT, so V equals nRT over P. And the last mark was for the answer. So there were some people who did get some working marks, but may have missed out on one of those things because it was quite difficult to do the moles and the 2 conversions and the rearranging. Okay, so that's 4 marks. Next question. Suggest a name for this type of reaction that iron 3 nitrate undergoes. If you look at the equation, you will see that they say in the question it's heated and it breaks down effectively. So that, what they're looking for there is decomposition, or more accurately, although you didn't have to write that, thermal decomposition. It's not combustion because it's not reacting with oxygen. Part C, suggest why the iron 3 oxide is pure. Assume a complete reaction. So that means there is enough heat, they have heated it for long enough. What they're looking for you to do is to look at the reaction a little bit more carefully and look at the other products. You will see that all the other products are gases. So therefore, they are just going to escape. So you are going to be left with just that solid iron oxide. Okay, those are just 2 that they've put in at the end to give a couple of extra marks. Okay, question 3, structure and bonding. Question 3, nickel is a metal with a high melting point. State the block in the periodic table that contains nickel. So look at where it is. You should know your S, P and D block and where that is. Nickel is in the D block. Most people got that correct, well done. If you wrote transition metals, that's not a block. So just stick with D block. Part 2, explain in terms of its structure and bonding why nickel has a high melting point. So they tell you in the question that it is a metal. Hopefully you've worked out that it's metallic bonding. You don't get any marks for identifying that it's metallic bonding. You get a mark for explaining that metallic bonding and why it has a high melting point. The first mark is for the idea of you've got positive ions and delocalized electrons. And the delocalized bit, as you can see if you looked at the mark scheme, the delocalized bit is very important. So that's for the first mark. The second mark is for the idea that there is a strong attraction between these 2 things. So the sentence, strong attraction between positive ions and delocalized electrons, gets you 2 marks. Part 3, draw a labelled diagram to show the arrangement of particles in a crystal of nickel. In your answer, include at least 6 particles of each type. So they're asking you to draw this metallic bonding. Very, very straightforward it should have been. And I've shown you this diagram before. You get 1 mark for that. That is very, very simple. And the second mark is for putting the plus charge in. You don't actually have to show the electrons. It's not in the mark scheme, but I often show it as a little wiggly line, as you know. Then labelled with a little arrow, showing that that's the sea of electrons. But actually, they're not really looking for that. They're mainly just looking for the particles, the ions. Okay, next question. Why is nickel ductile? Why can it be stretched into wires? Because it's the layers of ions can slide over each other. That word layers is very important. As you will see from the mark scheme, layers and ions are underlined. So that means you have to put them in. So the layers of ions can slide over each other. Some people wrote really good answers about the delocalized electrons moving as well, but this is really what they're looking for. Okay, so the next question. Give the full electron configuration of the nickel 2+ ion. Now this is difficult because you've got to remember that the 4s subshell fills first and empties first. So if I'm just going to write at the bottom what nickel would be as an element. So it's 1s2, 2s2, 2p6, 3s2, 3p6, and then it's 4s2 and 1, 2, 3, 4, 5, 6, 7, 8, 3d8. So that's what it should be as an element. I know you might not be able to read that very clearly. When it becomes the nickel 2+ ion, obviously it loses 2 electrons, but you've got to remember it loses from the 4s first. So what they wanted you to write is 1s2, 2s2, 2p6, 3s2, 3p6, leaving out the 4s, and then 3d8. That's the answer. Okay, part B, 2. Balance the following equation to show how anhydrous nickel 2 chloride can be obtained from the hydrated salt. So, balancing, it's not easy because they're not going to make it easy. There's a couple of different ways to approach it. If we just count up at the beginning what's balanced and what's not, the nickel, we've got 1 on each side, that's fine. The chlorine, we've got 1, 2, 3, 4 on the left, and we've only got 2 on the right. The hydrogen, we've got 12 on the left, just 1 on the right. The oxygen, we've got 7 on the left, and just 2 on the right. So, what I'm going to do first is go, okay, well, we need to sort out the oxygens, the hydrogens, and the chlorines. So, if I think about the hydrogens and the oxygens, we've got 6 H2O on the left, so that means we're going to have 6 hydrogens plus times 2 is 12. So if I go, okay, well, we've got 12 hydrogens there on the left. I can't remember if I said that originally or not. So we've got 12 hydrogens here. So, therefore, we need to have 12 on the left. So let's start off by doing that. So now the hydrogens are balanced. By doing that, we've then messed around with the chlorines. We've now got 12 plus 2. Let me show you where I'm pointing here. So we've got 12 chlorines there, plus 2 there. So we've got 14 on the right-hand side. I've got 2 there, and then there's 2 there. That's obviously 4. That's not enough. If I was to make the chlorines balance by putting 6 there, so by doing that, I've got 12 there, plus 2 is 14. So that's all balanced. Let's now think about what we've got left, because as I've just shown, the chlorine is balanced, the hydrogen is balanced. The sulfur, by doing this, we've now made 6 sulfurs. So let's put a 6 there. And let's count it all up again. So, nickel, still 1 there, that's fine. Chlorine, 2 there, plus 12 there is 14. 12 there, plus 2 there is 14. Oxygen, 6 there is 12, and we've got 12 there. Sulfur, 6 there, 6 there, and I think that's everything. This is balanced now. Okay, and I know that can take a little while, but that's balanced. Next part of the question, identify one substance that could react with both gaseous products. What they're wanting you to look at here is the properties of HCl and SO2. They expect you to know sulfur dioxide is an acidic gas. Obviously HCl is an acid as well, so what they're looking for is any base. Sodium hydroxide is an obvious one, but you could have calcium oxide, calcium carbonate, anything that you know from flue gas desulfurization. That will work as well. Okay, next question. Right, question 4. Name the strongest attractive force between two ammonia molecules. Okay, ammonia, as you should know, is NH3. So therefore we've got nitrogen bonded to hydrogen. That should be very easy, and most people got it right, so well done. Hydrogen bonds. Don't just write hydrogen, it's got to be hydrogen bonds. Part 2, draw a diagram to show how two ammonia molecules interact with each other. Include all partial charges and all lone pairs of electrons in your diagram. In case you're wondering why they've sort of kind of emphasised it's got to be in the liquid phase, it's because if you think about it, when they're in the gas phase, those molecules are far apart, so there are no intermolecular forces. So the only reason that they've said about it being in the liquid phase is just to say that actually there will be intermolecular forces. So, one molecule of ammonia, NH3, another one here. If it says 2, I wouldn't recommend that you draw any more, because if you make a mistake you will lose marks. So there's our two ammonia molecules. Include all partial charges. So that's your delta pluses and your delta minuses. Nitrogen is going to be delta minus each time, and then hydrogen is delta plus. You get 1 mark for your correct partial charges. And actually, in the mark scheme, it says you don't have to draw all of them, as long as for each molecule there's a correct nitrogen and hydrogen. Okay, so that's 1 mark. Second mark is for the lone pairs. Nitrogen, each nitrogen atom has a lone pair, like so. And the third mark is for drawing a hydrogen bond from the lone pair on a nitrogen to a hydrogen on another molecule. So a little dotted line there is perfect. Okay, if you haven't drawn the hydrogen bond from the lone pair, you would lose that mark. If it's just from the nitrogen but not from the lone pair, you lose that third mark. Okay, part B. State how the bond between ammonia and boron trichloride is formed. A lot of people correctly identified that it was a dative covalent bond, correct, but they wanted a bit more detail about how that bond is formed. The idea is that both electrons in that bond come from the nitrogen or the NH3, and they're donated to the boron. So just saying it's a dative covalent bond is not enough. It's the idea of using the lone pair that is on that nitrogen, and that it's going to form a bond, but both electrons going from the NH3 to the B. Okay, next part. Part C. Give the meaning of the term electronegativity. This is a definition that you've just got to learn. I'm not going to write it out again, it's in the mark scheme. The power of an atom to attract electron density towards itself in a covalent bond. Learn it. C part 2. Suggest the formula of an ionic compound that is formed by the chemical combination of two different elements from table 3. So, ionic compound, metal and a non-metal. If you look at the table, the only one there that is a metal is lithium. So you want lithium with something. They will accept either LiF, Li2O or LiH. I think probably the most obvious one is LiF, lithium fluoride. Remember, they want the formula. Lithium is in group 1, so it's a 1 plus. Fluorine is in group 7, so it's a 1 minus, so one of each. Part 3. Suggest the formula of the compound that has the least polar bond and is formed by chemical combination of two of the elements from table 3. So the least polar bond, they expect you to work out here that the least polar bond is when you're going to have the smallest difference in electronegativity. So what's the smallest difference? Well, we've got hydrogen here, which is 2.1, and boron, which is 2.0. Very close together. So the compound which contains boron and hydrogen, boron is in group 3, so it's going to react with 3 hydrogens, so BH3. I know that is quite difficult. This is the idea, it's quite a challenging question. Okay, next. Question 5 should be fairly straightforward, a lot of these. One of the compounds in paraffin is a straight chain alkane dodecane, C12H26. Give the name of the substance from which paraffin is obtained. State the name of the process used to obtain paraffin from this substance. Crude oil and fractional distillation. On the mark scheme, very straightforward. 5b. Write an equation for the incomplete combustion of dodecane to produce gaseous products only. So there's a few clues here. Firstly, write down that the formula of dodecane is C12H26. I had a lot of people copying that incorrectly, which was a real shame. If it's combusting, it's reacting with oxygen. It's incomplete combustion. So that means it's not going to produce carbon dioxide, it's going to produce either carbon or carbon monoxide. The fact that they've said gaseous products means that they want you to write carbon monoxide, which is a gas, plus water, which is always produced. You've now got to balance it. 12 carbons on the left-hand side, so we need to put a 12 there. We've got 26 oxygens there, so we need to put a 13 there. When you count up the oxygens on the left-hand side, 12 there, 13 there is 25. So 25 over 2 is 12.5. You can either write it as 12.5 or 25 over 2. Okay, part C. Oxides of nitrogen are also produced. Explain how these are formed. The idea being that nitrogen and oxygen react together, but only at high temperatures. Okay, that's from the mark scheme. That should be fairly straightforward. C part 2. Write an equation to show how nitrogen monoxide in the air is converted into nitrogen dioxide. So, nitrogen monoxide, NO. It's going to be converted into nitrogen dioxide, NO2. How is it going to do that? What is it going to react with? The idea being that the air, there's oxygen in the air, so it's going to react with oxygen, O2. You then need to balance it. You can put a 2 in front of the NO and the NO2, or you can just put a half in front of the O2. Either one is fine. Deduce an equation to show how nitrogen dioxide reacts with oxygen and water to form nitric acid. So nitrogen dioxide, NO2, reacts with oxygen and water to form nitric acid. And they even give you the formula of nitric acid. There are no other products. They would tell you if they were. Balance it as it is. Okay. Again, you can use halves if you want. If you don't want to, a 4NO2, nothing in front of the oxygen, 2H2O makes 4HNO3. Okay, part D. Dodecane can be cracked to form other compounds. Give the general formula for the homologous series that contains dodecane. Now, the big clue is it's an ane. It ends in ane, so it's got to be an alkane. You should know the general formula for alkanes is CnH2n plus 2. Part 2. Write an equation for the cracking of one molecule of dodecane. So that's C12H26. Into equal amounts of two different molecules, each containing the same number of carbon atoms. So, two different molecules, same number of carbon atoms. So they're both going to have C6. Because 12 divided by 2 is 6. So, some people just divided then the hydrogens by 2 to make C6H13 twice. However, that molecule does not exist. What you've got to do is make an alkene, C6H12, and an alkane, C6H14. State the empirical formula of the straight chain alkane that is formed. So that is that one. The empirical formula would be C3H7. Empirical formula is the simplest whole number ratio, divided by 2. The catalyst used for cracking is zeolite. Part 3. Explain why the melting point of dodecane is higher than the melting point of the straight chain alkane produced by cracking dodecane. Very, very simple. Firstly, think about what structure they have. They are both simple molecular substances. Dodecane is a bigger molecule. So, that's what you get the first mark for saying, is that dodecane is a bigger molecule, or it has more electrons. So therefore, second mark, there are more van der Waals forces between molecules. Look at the mark scheme. The between molecules bit is underlined. That means you've got to put it in. A lot of people lost that second mark because they didn't say between molecules. If you put anything in there about breaking bonds, or anything to suggest that you might be breaking the covalent bonds, you would get 0. Okay, next question. Give the UPAC name for the following compound. Wow, this was a really tough one. And they deliberately did it. Really, really made it hard. Okay, so, firstly, looking at it, we can see it's an alkane. It's obviously got branches, but it's not an alkene, it's not a haloalkane. So, look at the longest carbon chain. And it's straight down the middle there. We've got 6 carbons in a chain, so it's going to be some form of hexane. The problem is, we have got all these methyl groups here. There are 6 methyl groups, so that is hexamethyl. Okay, I know we haven't always gone that far in terms of that many methyl groups, but hopefully it makes sense. If you've just got 1 methyl, it's methyl, then dimethyl, trimethyl, 4 would be tetramethyl, 5 would be pentamethyl, 6 is hexamethyl. So where are those methyls? They are on that carbon, and that carbon. If we number from here, that's carbon atoms 2, 3, and 4. So the full name is 2, 2, 3, 3, 4, 4, hexamethyl hexane. A lot of people got very close to that name, maybe didn't put all the numbers in. You can't just write 2, 3, 4. It has to be 2, 2, 3, 3, 4, 4. Some people wrote 1, 2, 3, ignoring that this carbon atom was actually carbon 1. Some people, and I was a bit generous, if you wrote hexmethyl instead of hexamethyl, I still gave you the mark, because I thought you did very well to get to that stage. The type of structural isomerism shown by this compound and dodecane. Same molecular formula, different structure. That's the definition of structural isomerism, but how has it changed? We haven't got any functional group, so it's not position or functional group, it is chain for the second mark. Okay, part F. Dodecane can be converted into halododecanes. Deduce the formula of a substance that could be reacted with dodecane to produce 1-chlorododecane and hydrogen chloride only. So, what's happening here to get from dodecane to 1-chlorododecane? You're adding chlorine. That should be fairly obvious. Hydrogen chloride being the byproduct is that one of the hydrogens from the dodecane has come off to react with the other chlorine atom. So you're just adding chlorine. The formula should be Cl2 because they do ask for formula. So if you wrote the name, that is not what they want. Okay, so we're getting to the end now. Question 6. So we've got some tricky calculations here. Calcium phosphate reacts with nitric acid to produce phosphoric acid and calcium nitrate. A 7.26 gram sample of calcium phosphate reacted completely when added to an excess of aqueous nitric acid. Calculate the concentration of phosphoric acid in this solution. So they want the concentration of the phosphoric acid, which is that. They've given you information about the calcium phosphate. So the first thing we have to do is to work out the moles of calcium phosphate. We do that by doing mass over MR. The mass is 7.26. The MR is 310.3. Now, a lot of people got that MR incorrect, which is a real shame, and I'm not sure why. It might be because you were looking at a different compound, maybe calcium nitrate, or you just added it up wrong. So please make sure you double check your answers. So 7.26 divided by 310.3 is 0.023396. And then it carries on, so I'll just write it like that. That would actually get you 2 marks. You get 1 mark for working out that MR, and then 1 mark for doing that calculation to get that answer. Okay, so we've now got the moles of the calcium phosphate. We now need to work out the moles of the phosphoric acid. It's quite a nice 1:2 ratio. So actually we then do 0.0233 times by 2, and that should give you approximately 0.0467 or thereabouts. But the third mark is for actually that timesing by 2 there. Okay, then we've got the moles of phosphoric acid, we need the concentration. Concentration is moles over volume. So we take that moles and we divide it by the volume. The volume that they've given us is 38, but remember, you have to convert your volume into decimeters cubed. And actually that's what the 4th mark is given for, is for doing that conversion to get 0.038. So then the last mark is for the answer, which should be 1.23. It says give your answer to 3 significant figures. If it's not, you would lose that mark. The units are moles per decimeter cubed. Okay, 6A part 2. Calculate the percentage atom economy for the formation of calcium nitrate. Give your answer to 1 decimal place. This should have been very easy, but a lot of people didn't get it. So the formation of calcium nitrate. Calcium nitrate is up here. You need to take the big numbers into account. So you want to work out the MR of calcium nitrate, times it by 3. So it should be 492.3 divided by the total MR of all the reactants, including that 6 in front of the HNO3. The total there should be 688.3. Times 100, that gives you 71.5%. Okay, 6B, write an equation to show the reaction between calcium hydroxide and phosphoric acid to produce calcium phosphate plus water. It's tricky because you've got to work out some formula yourself. Calcium hydroxide is CaOH2. Oops. They expect you to know that OH has got a 1- charge and calcium has a 2+. So 2 hydroxides there. Phosphoric acid, they give you the formula of that on the previous question. To produce calcium phosphate. This is the really tricky one. Calcium is 2+. Phosphate, PO4. If it's got 3 hydrogens, that means it's going to have a 3- charge. So, we'd actually need 3 calciums and 2 phosphates to balance it out. So the formula of calcium phosphate is Ca3PO4 plus water. And then remember to balance it. 3 calciums in the phosphate compound there, so we need 3 there. We've got 2 phosphates there, so we need a 2 there. And then when you count it all up, we actually need 6 waters. Okay, not easy at all, but it is challenging. It's designed to make you think. Okay, part C. Calcium dihydrogen phosphate can be represented by that formula where X is an integer. A 9.76 gram sample contains 0.17 grams of hydrogen, and they've given you the masses of phosphorus and oxygen. Calculate the empirical formula and hence the value of X. Show your working. If you do not show your working, you do not get all the marks. It says in the mark scheme, if you get the answer with no working, only allow 1 mark out of the 4. Okay, so I've shown you how to set up empirical formula questions. So this is how I would do it. You've got the calcium, the hydrogen, the phosphate, or the phosphorus, and the oxygen. Now they've given you the mass of hydrogen and the phosphorus and the oxygen. But you need to work out yourself the mass of calcium by taking the 9.76 minusing the hydrogen, the phosphorus and the oxygen. What you are left with is 1.67 grams. You actually get 1 mark for working that out, the first mark. The second mark is for dividing by the correct atomic masses. Should be very straightforward. Look at the periodic table. Calcium is 40.1, hydrogen is 1, phosphorus is 31, oxygen is 16. When you do that, then divide by the smallest, the ratio you should get is 1 to 4 to 2 to 8. What you can then do, there's a couple of ways to get the fourth mark. The third mark is for the ratios. The fourth mark, you can either write CaH4P2O8 or work out, well actually, if we look back at the original question, that X, looking at that, therefore it must be 2. So X equals 2. Okay, as I said, you have to show your working to get all the marks there. Okay, the last question. Thallium is in group 3 of the periodic table. It reacts with halogens. Draw the shape of the TlBr3 2- ion and the shape of the TlCl4 3- ion. Include the lone pairs. So, thallium, group 3, it tells you. So, if we look at the TlBr3 one first, it's obviously going to form 3 bonds with the bromines. But then it says it's 2- because thallium's in group 3, so actually all 3 of its electrons have been used up. The fact that it's 2- means that we know it's gained 2 electrons. So actually it will have a lone pair. And you get the first mark for that shape, showing 3 bonds and 1 lone pair. The TlCl4, 3-. So it's the same kind of idea. It's got to have 4 chlorine bonds. But then the fact that it's 3- means that it's gained 3 electrons. It's obviously gained 1 of them to bond with one of the chlorines because it would have used 1 there, 1 there, 1 there. That's its 3 in its outer shell. It's gained 1 there to react with the chlorines, which means it's still got 2 more. So it has a lone pair. So the second mark is for the shape of that, with 4 bonds and 1 lone pair. Name the shape made by the atoms in TlBr3 2- and suggest a value for the bond angle. So 3 bond pairs, 1 lone pair. That's a standard shape. It is pyramidal, same as ammonia. The bond angle is 107 degrees, not 109. They would allow 107 or 107.5. Okay, part B. Thallium 1 bromide is a crystalline solid with a melting point of 480. Suggest the type of bonding and state why the melting point is high. Now, you're not expected to know a lot about thallium, but it's in the same group as aluminium. It is a metal. So you've got a metal and a non-metal. So it's an ionic compound. 1 mark for that. 2 marks for the very standard answer of strong attraction between oppositely charged ions. If you mention anything about covalent molecules, intermolecular forces, you get 0. And part C, write an equation to show the formation of thallium 1 bromide from its elements. So we've got thallium, Tl, bromine, which you should know is Br2, and up here they give you the formula of thallium bromide, TlBr. And just balance it. 2 there, 2 there. And that's it. Okay, that's the Unit 1 paper done. If you have any questions, you're still not sure why you didn't get certain marks, then please come and see me. Okay.